Okay guys, good morning. So today we are finally going to start talking about equations with the variables on both sides, all right? So we spent a lot of time on distributive property equations like the first one and like terms equations like the second one here. But today we're going to talk about what happens if we have variables on both sides. So I'm going to quickly do the do now. So you should be, as always, doing the same, right? You should be pausing it. You should be working at your do now questions and then unpausing when we go over it. So I have negative 3x plus 24 is equal to negative 18. I'm going to add negative 24 on both sides. And I'll bring my work up here. That's going to give me negative 3x is equal to negative 42. I'm going to divide both sides by negative 3, and it's going to give me x equals positive 14. For the second one, I'm going to combine my like terms since they're on the same side, and that's going to tie into what we do today. That gives me negative 9c minus 21 is equal to 24. I'm going to add positive 21 on both sides, which gives me negative 9c is equal to 45. I'll bring my work up over here. I'll be dividing by negative 9, and I've got c is equal to negative 5. Now, again, the one thing that we really haven't seen, and then we've pretty much covered everything there is to say for the most part about, multi-step equations other than, fractions and decimals and stuff like that, which doesn't change the way we solve them, is what happens if you have variable terms on both sides, right? So if we look at question number 2 here, we have variable terms, but they're on the same side of my equal sign, right? The equal sign's like my barrier. So let's take a look at something like this. I've got like terms, but they're on different sides. And again, this is my equal sign. This is like my barrier here. So what am I going to do? Well, I want to get rid of something, all right? And I see that my right side only has 8x, right? That's all my right side has. It just has 8x on it. My left side has a constant, and it's got a variable term. So what I want to do is I want to keep the 8x isolated, but I need to eliminate that 3x. And the way we eliminate terms is adding their opposites on both sides, and that's true for a variable term just like it's true of a constant. So let's see what happens when I add. Well, 3x plus negative 3x is 0. I bring down 55, and 8x plus negative 3x is 5x. So I bring down 55 is equal to 5x. I divide by 5, I get x is equal to 11. Now I'm going to hold off on a check for one of the more sophisticated ones that we do. But I do want to show you an example of what not to do. All right. What should I not do? Well, I shouldn't do this. Now, why should I not do that? Well, here's what it's going to give me. All right, so this is what I'm not going to do. Now, could I solve this equation by adding 5x and by dividing by 5 on both sides and get x is 11? Sure. Here's what's going to happen, though, guys. I've been doing this a long time, and I've seen this more times than I can count. Someone's going to add negative 8x on both sides, but instead of putting up the correct equation, which is what I have in orange, you end up putting this, right? The equal sign mysteriously moves. It morphs because we're used to having it between the two terms and not equal to 0. And now what's going to happen? Or I'm sorry, we're going to end up with this. 55 equals negative 5x, and x is equal to negative 11. So you want to be really careful. So a good guideline for these types of equations, for all the equations we're going to do up until maybe the very end of the year, you never want to leave one side of the equal sign blank, right, as in with 0. Okay, so when we have a choice at the beginning, do I eliminate the 3x or the 8x? We're going to say, well, the 8x is by itself. If I eliminate the 8x, that's going to leave my right side of my equation with nothing. That's going to make it more complicated for me to solve, and I'm probably going to end up making a mistake. And we'll talk about that as we go through this. So here, same dilemma, right? I've got the negative 9y on my left. If I eliminate the negative 9y, it's going to leave my left side with 0, and more often than not, the equal sign mysteriously jumps over the 15. So I don't want to do that. I want to eliminate that negative 12y, which should be pretty easy, right? We know we can eliminate any term by adding its opposite on both sides. All right, so negative 9y plus negative 12y plus 12y is 0. So I bring down my 15. And negative 9y plus positive 12y is 3y. Well, that was pretty easy, right? 3y equals 15. I divide by 3, and y is 5. Okay, so again, general guideline here, you don't want to leave either side of the equation blank, as in with 0. Not that it's mathematically wrong, but what happens next is generally wrong, in that we generally tend to just shift the equal sign over. Now, this is a more typical equation with variables on both sides, right? Most equations that we see will have variables on both sides as well as constants. So technically for an equation like this, you have 4 different choices. You can eliminate any of these terms and make it essentially a 2-step equation. You could eliminate negative 4x by adding 4x on both sides. You could eliminate 10 by adding negative 10 on both sides. You could eliminate negative 6x by adding 6x on both sides. Or you can eliminate 16 by adding negative 16 on both sides. Now, in general, you want to eliminate a variable term. If I eliminate a constant, it's going to give me something that looks like my previous equations, where I have variables on both sides and a constant on one side. We tend to make a lot of mistakes with that. If I eliminate a variable term, it's going to give me a 2-step equation, which we spent a lot of time on. Not too many of us are going to make mistakes with 2-step equations. Now, my general guideline is, if you have the choice, now it's not going to be true for the first 2 that we did, but if you have a typical variables on both sides equation like this, where we've got variables and constants on both sides, my general guideline is eliminate the smallest variable term first, as in the one with the smallest coefficient, because that will ensure that our final 2-step equation has a positive coefficient, so I'll explain. I've got negative 4x and negative 6x. Now, negative 6 is smaller than negative 4, so I'm going to eliminate negative 6x by adding positive 6x on both sides. Now, guys, you really need to be very careful with your placement of the terms. If you put the positive 6x underneath the 10 instead of the 4x, we're going to have problems, okay? So this is going to kind of let me know what your work looks like when I see it. It's going to let me know how much you really paid attention and took notes and really kind of followed along with the videos here. So negative 6x plus 6x is 0. Negative 4x plus 6x is 2x. I don't think too many of us are going to have trouble with 2x plus 10 equals 16. At least I hope not. All right, so I'm looking at 2x equals 6, which will give us x is 3. And now I think it's time to take a look at a check. All right, so when we do our check, as always, right, nothing changes here. We know we're going to rewrite our original, and I'll put it down here where I've got a little more space. And we know we're going to substitute using parentheses, as we always do, right? Again, nothing new here. So we think x is equal to 3. So I've got negative 4 times 3 plus 10 equals negative 6 times 3 plus 16. Negative 4 times 3 is negative 12 plus 10 equals negative 6 times 3 is negative 18 plus 16. Negative 12 plus 10 is negative 2. Negative 18 plus 16 is negative 2. And we're happy. That proves that, in fact, we did this correct and x was equal to 3. So again, guys, just as some guidance, if you've got a term that's on its own, right, that term's going to stay there. You eliminate the other variable term. If you have, as most of these will, what I'm looking at here are variables on both sides, you can eliminate either variable term first. My advice is always to eliminate the one with the smallest coefficient, which will always end up giving us a term here with the positive coefficient. All right, so now this is kind of like the pinnacle, right? So this equation, not that it's super sophisticated, but it's got everything. It's got distributive property. It's got like terms. It's got variables on both sides. So this would be a good assessment. So if I was you guys, I would pause the video, see if you can work it out on your own. And if when you come back and pause it, you do the same thing I did, I'd say you're in a pretty good place. So let's take a look. So I'm going to distribute my 6. So 6x minus 6 minus 4x equals 29 minus 3x. I'm going to put up my barrier here. So any like terms on the left can be combined, but I can't mix them up with like terms on my right. So I can take the 6x, and I can take the negative 4x, but that's it, right? I'm not going to take anything from the other side because that barrier really is still there. So now I need to eliminate one of my variable terms, right? Well, what I said before was you want to try to eliminate the one with the smaller coefficient. So there's going to be people that do this and they add negative 2x on both sides. Guys, that's perfectly fine. Okay, if you added negative 2x on both sides, you're going to end up, I'll explain when we get to that part. But for me, I'm going to eliminate my smallest coefficient, which is negative 3x, by adding its opposite on both sides. This should give me a nice, easy 2-step equation, right? 5x minus 6 equals 29. Right, so that tells me that 5x is equal to 35, which tells me that x is equal to 7. Now here's what's going to happen. for those of us, right, if you did what I asked you to do and you paused this, and you did it by adding negative 2x on both sides instead of adding the positive 3x on both sides, what you're going to end up with at the end is this. You're going to end up with negative 35 equals negative 5x, and you're going to divide by negative 5, and you're going to get x is equal to 7. You're going to get the same thing. So that rule about eliminating the smallest variable term, that's not like an absolute. That's based on, years of experience. That's kind of my advice as far as, what's going to prevent the most mistakes. But if you did it that way and you got x equals 7, you could pat yourself on the back, you did the right thing. So this is our now try. This is our little assessment, right? How you feel, did I understand this lesson? Did I not? So it'd be a good idea to pause it now, right? And then when you're done, right, of course, you come and unpause it. So I'm going to take a look at number 1, and I have coefficients of negative 9 and negative 3. So I want to eliminate my smallest one. So if I want to eliminate negative 9x, I'm going to add its opposite on both sides. Negative 9x plus 9x, of course, is 0. Let's be careful, guys. I'm bringing down the negative 11. Just like when we solved two-step equations and we had a negative coefficient as the middle term, we need to bring down the terms with their signs, right? Negative 9x and 9x is 0, but that negative next to the 11 doesn't just disappear. So now I've got negative 3x plus 9x is 6x, and I, of course, bring down the 7. Nice, easy two-step equation. I'm going to add negative 7 on both sides. 7 plus negative 7 is 0. Negative 11 plus negative 7 is negative 18. I'm going to divide both sides by 6. And I get x is negative 3. And if I check it, which you guys I'm sure are doing, on the left side, negative 9 times 3 is 27 minus 11 is 16. On the right side, negative 3 times negative 3 is 9 plus 7 is 16. All right, the second one's not that different other than the fact that I just have x as in coefficient of 1, right? No coefficient written. This one, the choice should be easy, right? I'd much rather eliminate the negative coefficient than the positive coefficient. So I'm going to add positive 4x on both sides to eliminate my negative 4x. So negative 4x plus 4x is 0. Bring down my 11. X, which is 1x, plus 4x is 5x. Let's make sure we don't make that mistake here, guys. So I'm going to just bring my 11 over, right? Should I bring it straight down? Sure, but then I'm going to have this empty space here. So now I'm going to add 9 on both sides. And again, generally we end up, if you follow the rules, with a pretty simple two-step equation. So I've got 20 is equal to 5x. And I've got x is equal to 4. And again, when you go back and check it, on the left side it's 11 minus 16 is negative 5. On the right side it's 4 minus 9 is negative 5. All right, so those of you at home, okay, if you're in school, this is going to be our now try. You'll have separate homework. Those of us at home, this is going to be our homework, okay? And you're going to pick 3, okay? Pick 3 to solve and check. So let me get rid of this here. All right, so again, guys, your homework is to pick 3 to solve and check. If you decide you want to do all 7, I will certainly give you some extra credit. I'll give you 15 points instead of 10. Number 7 obviously is going to be a pretty tough one. 5 and 6 are going to be tough too. All right, but you're going to pick 3 to solve and check, okay? So obviously they increase in difficulty. So if you didn't think you did so well, you're going to do maybe 1, 2, and 3, or maybe you want to try 1, 2, and 4. If you did okay, maybe you pick 1 from each group, or maybe you do 2, 3, and 5, or 2, 3, and 4. And if this was super easy for you, you're going to do 5, 6, and 7. All right, and again, guys, I'm going to keep reminding you, any questions, best thing to do is post a comment under where you're submitting your homework, okay? Because I will see it quicker that way versus, seeing it on your actual homework sheet, which I may not check the day of, right?